Hey James, hey everyone, welcome to another session of a smart contract Gladiator, but actually today we are going to explore some genuine stuff and genuine ideas. But it would be aligned with a small contract Gladiator agenda, which is we want to learn and advance topics within Cardano ecosystem, but mainly a smart contract. And one of the things normally people, especially developers, have to deal with is the blockchain itself, right? I mean, the testing, all the things that a project had to deal with in the testing phase. So there is this library, there is this repository, and there is this tool called private tester that the Cardano node issued that, and you can create your private tester through your already tool. So you don't need this repository actually, but this repository, which I'm going to share the link in chat, have several scripts, bash script, which inside the script folder.
Hello, guys.
Hello, welcome.
Hey, everyone.
And inside this, I mean, the whole thing about this repository is actually these scripts. There are also guides which we will go through them in order to install, not even just install, but actually configure if you have this executable. But the idea is we are going to use, let me zoom in a little bit, that there is a tool within Cardano CLI that we can actually create an instance of Cardano blockchain, whole Cardano blockchain. And we have the opportunity to customize this instance of blockchain. So we are not bound but by what Cardano already doing or the protocol, but actually we can change that. And if you have the Cardano CLI, and if you type Cardano CLI and --help, you'll see that there is a place, but by the way, let me show you the version. It is a kind of old version, it's not very new version, so 1.35.5, which is in my opinion, is the most stable one, but sure, you can go to the newer version. But I normally stay with the stable version, especially in the production level, then moving forward, because you know that inside Cardano, things get updated, not even Cardano, the whole blockchain, things might break, and about the Aura script, about the tools, about the transaction, the hashes, all of things related to that might change as well. So for example, if you use Cardano CLI, like newer version, it might produce a new transaction hash if you use Cardano CLI, like a lower version. So please bear in mind and keep in your mind that it's not the best idea always to being very updated. So if you are going to create your production level environment, keep that level until you are sure to change it. So this is my Cardano CLI version, and inside, if you run Cardano CLI help, it shows that there is a set of command under Genesis, you can call it section. And if we type Cardano CLI Genesis, and again --help, we see that there are things here that we can use to create our instance of Cardano blockchain. So we have a tool already, and it is within just a command to create a blockchain. And you don't need Nix, you don't need Haskell, you don't need anything of all those environments bothersome that we know of. You just need Cardano CLI and Cardano node, of course, for running your and creating first your instance and running your private blockchain. And you can see that, I mean, inside this repository and bash script, which we are going to through, we are going to see that how these switches is going to be used and why these switches exist actually, and how these switches have any relationship with the mainnet, with the things that we are using the Cardano mainnet. But this humble switch is the guide to create a blockchain. And you can, by the protocol parameter, which you are going to see, you can change this. So for example, you might say, okay, if I want to create Cardano, how big it can create, like how much resource or how many, if we could talk about the volume of this blockchain, it's completely up to you. It's completely up to you. For example, about the Genesis keys, which we are going to see that these keys are very special keys. These are not a pop key hash or verification key or signing key. They are something different. And in mainnet, we have 7 Genesis key. But this script, we will see that this script will create 3. And we see that here, if you clone this repo and if you go to the script folder, and there is this makefiles.sh, and inside that, let me zoom in a little bit. For this, you can just see. You can see that there are options for creating this stuff, like the network magic. Here is 42, which we are going to change it together and see that, well, we can have as long as we want, and these numbers, like we can make it like this big number or very small, because it's private. We are the kind of god of this blockchain. Therefore, we have a tool to initiate whatever we want. But the command for that would be for creating this blockchain would be actually this guy. And you see that there is this, not this guy. Yeah, it should be, I mean, copy the Genesis key, which here we are generating that. And there are pools also, Genesis pool, Genesis stake delegation, and so on. And the same process happened, I think, around 4 years ago when we migrate from binary to shell era, and there was this staking, and because at the beginning, those pools were centralized, like all of them were running inside the Cardano Foundation, IOG. But then there was this phase or transition phase to open up this pool so other people could come to participate in the blockchain. But this is the thing that happened inside that time. So they generate that. And is there any relationship between like his treaty? Like, for example, if I want to go with 7 and UTXO key, we are going to see what does it mean? 7 and this 2 and this like, okay, 23 stake key, and like this one should be 7. Maybe. This, but I should also, by the way, I should mention that this is a new to me. This is not something that I was working for. I just got introduced by Adrian about this 2 days ago. So I'm going to learn a lot of stuff today with you guys. So yeah, if you guys have any question, let me check that. Did Adrian came? No. Okay. As I felt that. So in order to run this repository, after cloning that, you can go to the install executable for the guide. And once you are there, The thing is, you need to just copy these two. Like you might have Cardano CLI inside your system, so you need to go to that location which you hold these binaries and copy that to this directory. And once you do that, we can go with other step, but there is a private DB sync as well. So if you think you are, if you think you want to create a dApp or an application or something about the data analysis or on-chain data or sentimental of data of blockchain, actually, this is another tool that you can use, and maybe that's a thing you need to use, because you can have your own Cardano DB sync as well. And Cardano DB sync is a database which normally we can use with PostgreSQL, SQL, or any relational database. And it will hold all the transaction and all the CBOR stuff inside that database. And once you have that, you can build your solution or your idea. So that's another thing that of course, now we are going to focus for creating this blockchain, but in top of that blockchain, we have a way for DB sync as well. So you can have actually your private DB sync and you can test stuff with it. And of course, this is a database, and the whole solution normally is taking this data and making something out of it. So that's the thing. But I haven't done it I don't think I'm going to cover this DB sync, but this is something that maybe in future we will cover it, and we will test something about it with you guys. But
this is a topic that'll fit great. Like as we move from, I feel like what we're doing right now is a really nice preview of what a dandelion focused and stake pool focused PBL would be like. And
yeah, exactly.
Running is a big part.
So yeah, here we can have private testnet and private DB sync, which especially if you are going to go to the path of dandelion and becoming a third-party blockchain explorer in whatever solution you want. It's normally that section is called blockchain explorer. This is the thing that you need to run, and I hope in that course we will cover it. But yeah, if you just copy this, you are good to go about this step. That's all you need to know. And then you need to come to the third guide, because the second guide is again related to the DB sync, because here is going to use PostgreSQL for handling the DB sync data and all this thing, but we don't need to do that. So then we are going to run to this the command inside this guide, and it's not that much really harder stuff about that. You need to just come into this like the SRC here means that the root directory of the Cardano private testnet, and then within here just running this command like script s and dash automate. That's all. And once you run that, you need to wait until this script do its thing, which we are going to see what this script is doing. But if we just look at to the messages, we see that generated Genesis with 3 Genesis keys, 3 non-delegating UTXO keys, and 3 stake pool and 3 delegating UTXO keys. And delegation relation and 3 delegation map entries, 3 delegation addresses, and so on. So these are really fundamental things. And maybe even you want to use this tool to become a blockchain developer, not a dApp developer. You want to expand that to become a blockchain developer, and you want to clone Cardano to build something upon that. These are the things that you need to look at, and like what are they? And some of them we will look to it, but to be honest, I do not know. For example, delegation relationship, I have no idea. Personally, I have no idea what is this. Or delegation map entries, I do not know. Delegating addresses, I can guess that it is a Shelley address, the address that consists of payment part and the staking part. But even the Genesis keys, I'm going to show you now, but I don't know what is it, because let me show you that if you, once you run that, it will create a folder called private testnet, and within it there are many stuff inside it. But if we go to the Genesis keys, you see that okay, these are the signing keys, and but their type is special. Their type is Genesis signing keys, not this normal key. And you might say, well, what is the normal key? In wallet, I can show, for example, this guy. A normal signing key would be something like this, like a payment extended signing key, or for the staking part would be a stake extended signing key. So this thing is a standard. These are some type that blockchain understand, Cardano blockchain understand. So in our case, our keys are Genesis signing keys. And we have 3 of them. You see that there is VK, SK, and so on. And again, VK would be Genesis verification key. But inside Genesis, I think in no, these are sorry, let me find those keys that I'm going, those keys really interesting keys. Oh, okay. So Byron Gen commands. These keys are things that we don't know what is it, but these looks binary. So these keys, these 3 keys, we call Byron Gen command or Byron Genesis key, are the keys that's or blockchain is going to run with it. But if I just like kind of zoom out, the key looks like this, and it looks like it's binary. And if we go try to guess what the type is, I can go to the private testnet. Let me go there and see that. Sorry. See the private testnet, and it was Byron Jenke. And there is a tool called file inside any Linux. You can find it, and it will tell what is the type of that file. And if we go with Genesis key, like 00, that key, 00, that key, we say it's just, it couldn't even read its magic. So it doesn't have it. There is something within these files normally, like magic numbers, and by that it can understand what is the type of file. So personally, this is new to me. I don't know what is this. I don't know what this consists of, what is made of, and what is it doing. But inside Cardano, the mainnet, I mean, we have 7 of them. And in Voltaire era, these keys are going to be handed to community. And in order to issue a hard fork or something, these keys must be present. I don't know about the rule, like it should be 7 out of 7, 5 out of 7, or I don't know, like 3 out of 7, something. I don't know about that. Maybe if you guys know, help us out about this. But here actually we have 3. And as I said, these are really a special key that personally going to look to it and see what is it. But let's look at that now. Our blockchain or everything's running. But in another terminal, I'll open another terminal. In order to query or use this, you need to export this. I mean, you can put it, of course, in your profile or bashrc file. But if you come to the automate, there is this command like this guy, just these two lines. You need just to copy them and come in here and paste in them. And once you do that, you can query this private testnet. And let's do that. Cardano CLI, the command is Cardano CLI query tip. And then -- testnet magic 42. And we see that it's already in epoch 7, block 358. slot 3758. And why is that? Why these numbers? Well, inside, I think, makefile. Yeah, in makefile, here we define that what should those numbers be. But before that, let me show who's good. I mean, what these numbers coming from. Well, in Cardano, normally, if you guys remember, you need to download or you need to have these JSON files. Let me a little bit zoom in so we can see that. And I think would be in Genesis, in like this guy, like the Genesis here. We can see that like a slot duration is 1000, and this block version, all of these numbers, not only you can change them, like you want to, the transaction size is now 4 kilobytes. Well, you can change it to whatever you want, and we can test it together now. But these are the things that this blockchain runs actually. And if you, because you are the kind of god of this blockchain or private testnet, you can easily change it. And since you are running these 3 pools, 3 validators, node validator by yourself, those guys will also use your protocol JSON as well. But in normal way, in the Cardano way, in the mainnet, once there are changes here, every node must download or update these protocol parameters, and blockchain then use this parameter, which agreed upon, like if most nodes use that, and we can call that like hard fork or updating or something. And this is the thing that actually in Volta era, we are going to vote. We are going to vote for these numbers. Like right now, we voted, I mean, a SQL operator voted for the K parameter minimum. And the K parameter is here. Let me show you, like here in makefile, we have the K parameter. Security param is actually the K parameter. So now in this private testnet, the K parameter is 10, but in the mainnet it is 500, and we can and that voting is going to make it. We're going to see to 1000. So one thing I really like about this thing, that before voting, if something comes up, let's say, hey, we want to change these numbers, like the nodes to this or this K parameter now to 2000. Well, we have a tool right now to test this parameter, like which one is good. Like we don't want to give this opinion or these choices based on what we like. Like, okay, this number looks good to me. Okay, why? I don't know, just it has less 0 or it has more 0. Because it has more 0, therefore it's more decentralized. No, I mean, imagine someone choose something like a fate of a blockchain based on that. it's unacceptable. But here, if the person say, you know what, why I voted for this exact option, like for the K parameter of 1,000 or 2,000 or 1 million, I don't know, for sometimes like 5 years, 10 years later, because I ran this private testnet for myself and checked with this parameter and everything was fine, no problem. Therefore, I am advocating this number, which in my opinion is really crucial for Volter era for people to know about this, at least people who are going to vote inside that CIP 1690 for those council of even a stake pool or those 3 entities. Like they should have these run things with the, like you see that here with this bash script, all these parameters are decided here. And you saw that I just checked it like 42, right? Well, let me show you that I can just change that this number to something else, and everything works fine. So let me just stop that private testnet or blockchain, and let me go here. I mean, I'm going to use this like the search tool, and I'm going to search 42 and say that, hey, if everywhere you find it, like, if you are going to use VS Code or Vim, just make sure that you are going to target exactly 42, not any 42 middle of somewhere. So you see that there are many where these 42 exist. So instead of going through all these file, I just use this tool to search it and just change it to whatever number you like. What number you like? Let's go with I don't know, like what number do you guys suggest? Something exotic, like I don't know, 99999. How many? Did like 5? Okay, 6. No, okay, let's go for this. Maybe these numbers resonate with what we are doing, with 666. We are advocating for these people. So now we are creating a blockchain with this number. And if I replace them, you see that network magic is now 666. And let's run it. Let's test it. So again, I'm just coming here and again running this command. And again, let me remind you, you need to run this command at the root folder. So don't go inside the script folder and running this script. It doesn't work. You need to come and it is the way they design it. But of course, if you know about bash scripting, you can customize this much better, make it like giving you more messages, error handling, all sorts of stuff. But at least this repository is like that. So yeah, remember that. And if I run that and waiting a little bit, it said that, okay, I run this, and I need to wait until my stake pools and node and everything run. And once it's run, it will show me a message like this: congrats, your network is ready to use. By the way, this is running with protocol version 7, which now we are in protocol version 8. We are in the Valentine era. I mean, Valentine, after Valentine hard fork, not a Babbage, but it is old. But we can update that once you master this script and this command, you can update it. There's no problem. And now, if I don't need to run this command again, but if I run this 42, say, hey, I don't know, what is this testnet? But I can just, if I just go 666, and now I have my own testnet on blockchain running. And the slot here, I mean, this 1,000 we saw, the slot duration. 1,000 here means 1 millisecond. That's why it's really fast. And each epoch, I think, is around 2 minutes or something. So it's really, really fast, and but you can change it. You can change it. But when you see, we just ran it, and here we already have 30 blocks, 68, and we pass one epoch. So it's fast, but you can make it slow. You can make it faster, like so fast. So this thing are really customizable. But one thing that I hope we can kind of test today is just tampering with these fees, the number which determine about the fees. We want to see that how we can reduce and increase the fees. No, it would be kind of really interesting, right? I mean, imagine that you have a way to test fee. For example, because in the future we might say, hey guys, hey Cardano ecosystem and people, community, should we reduce fees? Should we increase it? Should we do this or what? But how do we know it works? Everyone should guess. Kind of, it should be a gambling situation, but no, we don't need that. So this is the introductory, and I've seen Adrian is here. Thanks God. How's everything, Adrian? I'm going
Hello. Sorry for being late.
No problem. Welcome back. So now I'm going to stop sharing and kick Adrian to the stage, so he will continue things. Adrian, before you came, I kind of introduced this stuff, the repository, and we ran this node. We kind of go through the installing and setuping, and we just did some changes. We just changed the magic number. See that, like this thing that we talk about. I kind of figured out how to do it. So yeah, that's all. But sure, you're free to start from the beginning.
If you want, you can go ahead with changing the fees.
Yeah, but the thing is,
you have
the script. You have the script to run those transactions very fast, but I haven't set up that. So if you would do it, it would take much less time.
Yes, sure.
Okay, so let me stop sharing and Adrian will continue. And if you guys, by the way, have a question or something, please ask. I know this is sound confusing, but well, don't worry. It is very new for us as well.
To share the whole screen, what do I need to click on?
If you sure, whole screen, and if you have multiple, you can choose a window or something. If you are running on VMware or like virtual machine or something. But if you are comfortable, yeah, you can go for sharing your whole screen.
Yeah, what do I have to click?
In the middle, there is a share screen, and once you click that in this Zoom.
Yeah, but now I can just choose one.
If there is a option like a screen one or something, like do you have?
Oh yeah, I see. Okay.
Screen one means entire screen. Yeah.
I think you should see my screen now.
Yeah, I do.
Okay, perfect. Yes, thanks to Mix, he already introduced the Cardano private testnet setup. I implemented just transactions for the new GPTE version. And I made a new directory. I called it run examples, where I just put it all transactions into one file. And now we can run it. I also made scripts for downloading the private testnet and going check out the correct tag. and also one for creating a new started private testnet, and also to delete the directory I called private, where we have all data for that run. Yeah.
And I should again mention that I forgot to say that once you clone that repository, you need to change that branch to a Babbage branch. So here, Adrian mentioned that it is a script he wrote does that. But if
Yeah, you
want
just have to
use that,
clone
you have
this
to,
repository, then you go into the folder and check out the Babbage
Babbage,
branch.
yeah.
Else you're in the older version and you will not work for the new Babbage era. Yes, we start the private testnet. I think Mix already explained that we create 3 different nodes and some addresses and UTXO keys. You can find them in the Cardano private testnet setup directory in the private testnet, and here you have everything. Yeah, and I made it. I just create new case and fund them with one of the wallets from the Cardano private testnet. I think it was strong. Yeah, I used one of the stake Gladiator case. The payment case, there are 3 different, and the payment ones are they have funds in it. We can query that.
And then Adrian, when you're running this, you're running 3 nodes on like different ports on the same machine.
Yes, you can. That's also in some file.
Yeah, inside, I think automate, you see that at the end of that file, there are this a command for configuring these 3 nodes, like 3 ports. In automate a script, automate.
Yes.
Around the end, I think you see that these. No, sorry, makefile. There are around the end and here. You see that
Yeah.
that these are the ports. A little bit of like the line 250, 260 something. Adrian. Yeah. These 3. So these are the called producer, the block producer.
So we have ports 3002, 3001, and 3003, I think.
Yeah, 3003, line 258. Yeah. And I should again remind you guys that these things is not really resource hungry. Like really, maybe you can run it on your Raspberry Pi or something.
I'm pretty sure it would work on the Raspberry. Yeah, if you can see, we don't
see it.
Don't even show up.
Yeah. And it's really great job IOG did, like creating a blockchain, running these nodes, and it doesn't break your system. That's really great. I'm really surprised they didn't advertise this that much.
Yeah, I think that's not from IHK, that repository.
No, not IHK, but this repository is like using those, like leveraging those tools, or like it's just creating this bash script, but underline the IOG, it's a Cardano CLI, Cardano node, all of them are running, right? So I think.
Let me ask you something, Mix.
Sure.
This expansion in the resources required to run the Cardano blockchain, it's not just coming from, you know, the size of the chain now. There's other reasons why it requires more resources than it used to.
Yeah.
What are those other reasons?
If you, for example, if you Adrian, go to the let me remember where is, yeah, in the makefile, at line 54. These are really important, that I believe that these will expand these nodes, and all blockchains getting heavy and big because of that. For example, the max transaction size now is 4 kilobyte here, but inside mainnet it's 16 kilobyte.
Right. Okay.
So once we change this and we are expanding this number, for example, MPC-THD, I think it is about the execution, like the number for I think
Right.
I'm
So
just
like these parameters that are smaller in this version,
yeah,
that they've expanded in the regular chain, they've done that because they think they can compensate with shit like input endorsers and Hydra heads and side chains and all that.
Yeah.
Okay.
Exactly.
Mix, I'm not sure if it's the fear are not just for the Byron network, because that's the Byron Genesis file.
So let's see, where is this? Like Sherry Genesis. Okay. Yeah, Adrian is correct. So inside the Genesis folder, Adrian, in private testnet, and inside there is a file Genesis, and just Genesis. Exactly above Genesis keys.
Oh yeah, sorry.
And the Shelly and the Genesis.json, if you come down around lines 40, you see that there is 16. So yeah, but I think it's changed, because now we are running with, if you have a protocol, I mean the JSON for the newest, but like the protocol version 8, we might see that the numbers change. So as far as I understand, and again, this is a person that just got introduced with this tool around 2 days ago, and my knowledge is limited. So I don't want to take my word or something as a granted or something. I'm just sharing my not even hypothesis, just understanding that once we increase these numbers, which is the path we are taking, we are actually getting more resource out of our systems, CPU, memory, hard, etc. And of course, these transaction size means, well, you know, it will consume more RAM, because the transaction size will go in mempool, and mempool means RAM. So like in protocol version, like this node version 8, you can see that requirement, like the recommended, or at least the minimum, is really got expanded, like I think 2 times bigger. All the resources is bigger than the previous version. Maybe they are making ready for the next hard fork or soft fork, but yeah, these numbers are the one. Like here, min UTXO value is 1 ADA. We can change it to something else. Like right now in mainnet, same thing here. You cannot send anything less than 1 ADA. But maybe in future, 1 ADA become, I don't know, $100. Imagine, I don't know, that's just hypothesis. And then we have to change it. But to what number? What number? Because if the reason is one ADA, stop attacking the network, like a dust UTXO. There is a attack called dust UTXO. And what number? Like there is a vote in Volter era. Should this go to 1 Lovelace? Should go to 100,000, 50,000, or something? Like now again, with something I said, like more zeros, more decentralized. Now about the fee, of course, less zero means less fee. So everyone say, I want to pay less fee, but lesser fee doesn't mean really good thing. It might compromise the network. But we have a tool, and I hope, I don't know, today we can just change it, this thing, because Adrian have some script for seeing these fees. And maybe we can just tickle, or I don't know, temper around. I don't know, have you tried that, Adrian, to just change
No,
it?
I haven't tried it.
Okay, great.
But I have something for you, Mix. I made the draw.io again for GPTE and everything. But it
Great.
looks really complex.
No problem.
Yeah, I started to make it just for contributor token and its different actions, and then later for the treasury also.
Maybe we can go through it, you know.
Yeah, sure.
But because, you know, guys, spot contract gladiator, I mean, the title is same, but the content now is we are focusing on Damio mainly. But sure, we can talk about it. Or if you guys want to see more about this private testnet stuff,
We can run the example I wrote.
Yeah.
And then we will see also the GPT current version. So yes, we have started our private testnet. Then we have to go to run examples. For now, only init to deny is working. I will add some more, like all treasury functionalities and the contributor reference validator functionality and everything. So now if we start that, we first create some 4 keys and addresses, or we can also call it wallets. We create one admin 1, which will be the treasury admin, 2 deciders, just to have 2 different escrow scripts where we can send the which we will refer with a contract token to, and 1 contributor. So now I wrote a script to fund them from one of the payment addresses from the Cardano private testnet wallets. Yeah, I just sent it, I think, 1,000 ADA to admin 1 and 50 to the other 3 wallets. And we mint some NFTs, 1 for admin 1, which we will use as the admin currency symbol for the treasury. And for each decider, also 1, which we will use as currency as escrow parameter for the 2 escrow scripts. Yeah, we can see them in the wallets or addresses. And
damn, that's a fast network.
Yeah.
Also, I should say that you don't need facet anymore, guys, because once you initiate this private testnet on those 3 wallets, you will get 300,000 ADA. You can expand it to millions.
Each wallet has 300,000 ADA.
You can go for millions of ADA. So you are not bound with number of ADA. So that's something I think really great for testing.
Yeah, I tested a bit, and we have to wait around 2 seconds for the transaction to be submitted and seen by the network. So, yes. Yeah, now we create all Plutus data, the testnet symbol policy, the contributor 1 policy, decider escrow 1 contract. Yes. Yeah, also I wrote them relatively quick and dirty, but I also described each step with the green lines. And yes, second one, The two escrow scripts are the same, but the only difference is the decider. One is decider 1 and one decider 2. Then the contract token, which we will later see referring to the escrow scripts with the token name, or the token name is the validator hash of each escrow script. Yeah, that's our contributor reference validator. And the last one is our treasury. I tried to name each file and wallet and the addresses in a way that we can create multiple instances of each contract. Like we could create admin2 treasury. Yes, then just a summary what we have created. Next, we mint some testnet symbols to the admin1 wallet. Like we can see here, just 1,000 for the beginning. Now we mint the contributor tokens. One with the 200 prefix, which will go back to the contributor. That should be this one. This one, yes. And the 100 prefix to the reference validator. So this one. And the datum of the reference validator is address, the address of the contributor it is representing, and also a number which is at the beginning 0, which is the completed tasks. Yeah. The current implementation is that the address can be changed by the contributor if the 222 token is present. And the task, the completed tasks is you can change if the contract trying to perform the action has both tokens and is referred by a contract token. But we'll see that later again. Yes. Now we minted token. No, that's not the correct. Yeah. Now we minted the token, contract token, to admin1 wallet, which is referring to escrow1, decider1 contract, like this one. And if we scroll up, remember the B91. And it's this one, the first escrow contract, the hash of it. And we use it as token name. And now we do the same for the second escrow script. For now, they're just sent back to the admin1 wallet. But if we lock the admin1 NFT at the contract, so yeah, maybe I should start with the contract token policy. Its only requirement is that it has the admin NFT in the transaction. So where do we have it? Only one is that it has the admin token in it. So if we lock the admin token at the script or at the contract, we could use that as governance. We could define the logic for minting and contract token in the contract. Yeah, and we also checked that the redeemer is a validator hash and it's later used as token name. Yeah, now we create a datum, which we will then use to lock it. So for now, the treasury validator is empty. Now we create a datum. The datum is a map of the hash, project hash, to the commitment data. So 111 is the expiration time, which is not used currently for anything. So I just, yeah, you can choose any number for now. Then we have 10 ADA commitment value and 10 project token. And then we also have a list, which is the contributor policy. If you scroll up, remember the F3. Where we have it? Yeah, it's the same. It's just this one. Yes, something went wrong. That's good.
Normally that error means a UTXO was spent and now we were
Yeah,
referring to
okay.
that. So
Maybe
kind of just
I should have increased the waiting time. So yeah, nevertheless, we have one contract token. I hope it's the first one. We have one contract token at the treasury. It should be two, but maybe my network is a bit overloaded because of also sharing my screen. Is that possible?
by the way,
And
we should mention that you cannot run that at least by this bash script forever. Those private tests.
oh yeah, the private testnet, it's around 1 hour, I think, or maybe a bit
Yeah.
more. Then it just stops, or you cannot query it anymore.
And it is for your own safety, because it will create these blocks and blocks, and you suddenly you see that your system gets full of this blockchain, full of this block. So that's not a good thing. You have, all these blocks produced very fast. Therefore, there is this called a kill switch mechanism for that. But you can change it. But you need to be aware that you might reach the limitation of your system, especially the hard drive.
So that's the inland datum of this one shown above. Yeah, it's the hash is just hash1, just for testing. Then the expiration time and the ADA commit and project token commit amount and the currency symbol of the contributor. Yes, now we also locked a fund UTXO with 100 ADA and 300 project token. The datum is just type, it's just the fund type. It's just this one, just fund type. Thankfully, it was the correct token we locked. Because if we have that one transaction was the second contract token, which is not locked yet.
What Adrian, why this transaction is so expensive? Like 1 ADA 130 times?
Yeah. The validators are under production.
Oh, okay.
I tried a bit with changing the types and so on.
By the way,
But
are you using?
we're also doing a lot of stuff in it. So wait, you can look at the treasury. So we have two actions.
Cases, yeah, that is nested.
Yeah, that's I played a bit with it.
No problem.
Yeah, we have to look that the output is back to the treasury, the not commit amount is back to the treasury. Then the contract token in and output is same. Then the contributor token datum should not change the contributor list who can commit to the project. Then we also have to perform some actions on the datums. On the token datum, we have to look that the project is now deleted after committing to it. Yes, the fund datum should also not change. The output to the contract is correct, and we also have to create the project details, which is used as the datum in the escrow script. We also have to build it and look that it's the same as the one. It is the correct one. And yeah, the contributor token is sent to the escrow script, and yeah, the correct datums, and the owner. Let's look at the types. So the project details are the project hash, the expiration time, the owner address, which is just the address of the treasury validator, so its own address. And the owner info is a built-in data type, which is the fund datum. That's just for the for later for denying the project, that the escrow script knows the datum, which it should use to lock the token again. Yeah, and what also makes it really expensive, we have to we cannot check for our own input. We have to look for all input from that address, because we have two transactions, the fund transaction and the contract token transaction. That makes it also
bigger
really
script context, mean bigger bigger transaction size, mempool, execution step, oh yeah, that makes sense, of course.
And also it's possible with this implementation to use more than one fund UTXO, because we just check that the all inputs and all fund transactions, UTXOs, are combined together. So if, but I think it will get way more expensive if you use more than one fund UTXO. So later for manage, we have also two actions, which we differentiate with the datum, because the fund UTXOs always have fund datum, and contract token datum is the one for the contract token.
It's not a good idea for two UTXO, for fund UTXO, or any two input. I mean, because guys, there is a vulnerability called double satisfaction. And it really might happen and occur when there is this two or more than one input. And by double satisfaction, I mean you can satisfy a condition, but that UTXO is not the UTXO supposedly should be.
Yeah, Mix. I know that you can.
Now, you know that, but
you can use more than one redeemer, yeah, sure.
And that's not a good idea. So it's really headache. So it would be really, I mean, by thinking, sticking with one UTXO as an input, or output can be anything, no problem, several output, but one input as a fund, as a fund UTXO would be better.
That's also a reason why it's so expensive, because of that implementation.
All those security checks.
Yeah, you have to treat all UTXOs the same way. You cannot differentiate between contract token UTXO and the fund UTXO.
But maybe in future, guys, when we have more space for transaction, for a script, for all of these, sure, in that time we can do that. And why is that? Because
I would like would be that I just can define it in the script context or anywhere else, that there are more than one transaction input is possible.
Yeah.
Which then maybe what would be nice to have is if we could provide the script and the redeemers just once for two transactions.
Yeah,
Because
exactly.
in
Which
this
is not possible.
implementation, we have
That's
two
really bad.
times the same redeemer, and we also have
Yeah.
to provide it 2 times the treasury script.
Maybe that would be Plutus version 3 or something. But as you can see, these things are the room for improvement. And once we solve this, we can batch transaction. We can have parallel transaction. We can have concurrent transaction. Like you can put several smart contract transaction into one, and it will really reduce time, and you can actually really use the power of UTXO in that time. But yeah, unfortunately, right now it's really expensive.
Okay, so that's the project details with #1, expiration time 111, and the escrow script hash, the treasury script hash. So that's it, and the fund datum, which is just the constructor. And now we deny the project. So we can see at the decider 1, escrow 1 address, there is no transaction anymore. So it's the contributor token is back at the contributor address, and the fund UTXO is back at the treasury. Yeah, and also, I forgot to show, the project is deleted at the contract token. So that's the contract token referring to the decider 1 escrow 1 escrow script, and the list is now empty. But the contributor policy is again the same. So, and for the contributor reference validator, I wrote it in a way that you always use it. So you use it. The last transaction was we used the redeemer use and check that the 222 prefix is sent to the reward address we defined in the datum of the contributor reference validator in the 100 prefix token datum. And that allows us to in the escrow validator that you just check that both contributor tokens are present, one with the 100 prefix and one with the 222 prefix. And for the distribute later, we use the, no, that's the wrong one. We use add completed task, which again checks nearly the same, but only difference is check updated datum, which is which just checks that the number increased by 1. Yeah, and we also check in where the transaction is coming from. So the address where of the decider 1 escrow 1 script, and we use a read only transaction. A read-only transaction, which is the contract token at the treasury validator, and we looked that it is present with the correct currency symbol, which is the contract token currency symbol. So that's a parameter of the contributor reference validator, the contract token policy. Yeah, so that's the whole trace for now. I will add one to for distribute, and I will also add some more examples like the treasury functionality where we just perform actions on the fund UTXOs and the token datums.
Great, Adrian, thank you. So guys, do you have any question in regards to this? You have, or if not, you are going to see this in much beautiful, front end face. So you're going to see that this is a product of Andamio, one of the product, of course. But now it's a testing phase. Yeah, I know it's complicated.
Yeah, it's really complicated.
We haven't scratched it. I mean, what I'm cooking, I think, showed. I mean, last week I showed it, but I haven't showed today. What I'm cooking is very complex. We can create all these instances, and Adrian is going to help me to make it more complex. So yeah, but that's the thing. Here in a small contract Gladiator, and here we are in the level of designing, like the smart contract design, how these interact with each other. Yeah.
I also made a try-o for it, but I made this that's just a simple one where I just have from the beginning, so all admins and contributors and all set up, and then just one action for each validator.
And by the way, we talked with Adrian to promise to use ChatGPT to create beautiful documentation. So yeah, that's
Mix. I also made some
new color.
Yeah, where I think we should think about governance.
Sure.
And each one is just the tokens we should lock in a governance contract or system.
Sure.
So like the admin for the treasury validator locked in a governance contract where we define the rules for how to add contract tokens and how to manipulate the token datums, add new projects or add new contributors to the list. And also for the decider, but that's, I think, not necessary for each contract, for each escrow contract. Because maybe if you have some kind of AI checking the GitHub repositories, I think it's not necessary to have it to lock the token in a contract.
We talk about it that we are going to create this different product, and each vendors or client wants to use it, they can choose each instance and they can implement it, or we can implement it for them. And of course, the governance option, and we had this talk with Roberto and James earlier today, that actually the governance, the potential of governance is not that much clear in the business side. Like how much this governance can be beneficial for business and clients, their user and so on. But that's an area we need to expand it and think about it, sure. But we have a contract in the different design for electoral commission. We might maybe, I don't know, maybe we can use that, or there is this headquarter contract. And by the way, Steve, you weren't in that session. I implemented one of the lovely design of human, invention, the corporate and enterprise style of smart contracts. So I know you would love that. We have C-level executive datums, imagine.
Yeah, it's great. I mean, like I think there's all kinds of management models possible with this. It's like, imagine Elon Musk actually had a little less hubris and he didn't want to be the man, but he could pick the guys that would keep him from becoming a real narcissist, and they could use this to keep things on an even keel.
Yeah, exactly.
So and just a guy, even an egotistical guy could do this and know, certainty,
Without a doubt, right? Like this, that's a decision ahead of us is do we place limits in what we document as the potential or how people use this thing? I don't think it's possible.
No, why would you want to?
Right.
I mean, we could hide some stuff, you know, and bring it out whenever we want to, but you know, you don't have to. I mean, you know, this is how people can reimagine real business, you know, real business.
Yeah, I agree.
I wonder if we can implement this code like automated incentive and automated punishment. So if you become egoistical, if you become narcissistic, the blockchain, the code itself will punish you. And
You know, I was thinking about
maybe
something
it's a
the other
bad
day.
thing. I don't know, you know.
And first of all, for everybody here at different levels of understanding this thing, like a basic version of these contracts is running under the hood of the Plutus PBL course. And, you know, the point is just to put some of the concepts in people's hands. This version of it takes it to a new level. It optimizes for a bunch of things and it future proofs it. It makes it easier for us to reuse it. But it also lays the scaffolding for clearer governance work. But if you've committed to any of the modules in the course, you've used an early version of these contracts already, okay? And even the list of what's possible to contribute to at the Treasury validator, we have that, right? So on pre-prod right now is a Treasury contract, the point of which isn't even to hand out tokens to people, even though it does that. Maybe you've noticed that every time you complete a course module, you get like 2 test ADA and 10 test gimbals. But that's not, it doesn't have to do that. The real purpose of the Treasury on pre-prod is that it lists what modules are live right now. Okay, so you can only commit to modules 103, 201, 2, 3, and 4. Okay. And if you tried to commit to something else, the validator would fail. So ahead of us is kind of thinking about what subset of this needs to be part of the PPBL course. We have to figure out what subset of this to teach about in the course because we want people to be learning Plutus along the way. And then at the cutting edge, there's this work that is turning these contracts into a product, and you can kind of hear some of the possible audiences here, right? Why would you overlay corporate language on this? So corporate-minded folks can understand it. And we think there's a legitimate business here getting this into people's hands. So we're going to be pushing forward on all 3 of those pathways kind of at the same time, right? The immediate course, the teaching within the course, and this cutting edge development.
We will have near-peer smart contracts and white-collar smart contract. Why not?
Yeah.
Well, I mean, you know, imagine the problem, right? There are so many family offices. That's what they call them in the investment world, you know, and they're basically big trusts, you know, handling inheritances for a lot of people who are, you know, heirs, you know, and this lets them do business in a trustless way with one another. You know, these large families or these large groups of people that are involved in a trust. I mean, even bullshit that we've been going through here at home with nonprofit organizations. This would be so helpful.
Mm-hmm.
Sorry.
Oh, without a doubt.
So, guys, what do you think about continuing the session for breaking the blockchain we have like this private blockchain? How about starting that?
That's the next step, breaking the blockchain?
Yep. So at the end, there is I mean, inside your search, if you search for min fee A, yeah, there is this min fee A. Let's change it. There is this two place. It's 44. But before changing that, I want to remember the first fee. You know, those script you run. I want to know the first one of the fee, or at least the first fee, and we want to remember how much was it. Yeah,
Yeah,
exactly.
submit the fund UTXO just. That's
Great.
really this one.
Yeah. So let's remember that, and let's change this. Let's see. Let's change that fee and see what happens. So there is these two places. I think you need to change it manually, kind of. They don't. So it's now 44. Let's go lower. Let's go 14. And there is this other place.
Yeah.
And 14. And again, we need to, I think, run the auto. And just to be sure that this did it change or not change? I hope it didn't change.
This one didn't change.
And that Genesis file?
I think it's enough to change it in the make file, I guess, because the other one is not.
Oh,
Maybe it will be created.
so that's a search for.
Yeah, now
okay,
it's
yeah,
not.
okay, 14. So okay, so let's see let's see what we have done. I wonder, like, let's see what was it, and see
So
what
now if we
happened.
find- Yeah, it's
Oh, look at the fee. It became less expensive.
nearly 1.8 or less.
So let's change it. Let's make it down. And there is a fee
Or
B
up.
also. Or up. Yeah, let's go for up. Let's see, like 100. And there is another one, 100. You see, guys, you have a tool just to enjoy, and in your weekend, if you get bored, you can just change this number and see what you think. And maybe you will find, because in my opinion, these numbers, I don't know what is the formula behind it, because there are those numbers. But maybe that's the thing. That's the sweet spot of these numbers. Like, why these numbers exist? What is their relationship with each other? I don't know. If you have searched about it, if you find something, I hope this session create this question in your mind. So once you look at, you find it, you say, I saw that. This is the reason. And then please share with us. So
Yeah,
wow,
now it's
you see, now it's
98,
more expensive. So somehow it changes, but it doesn't change it that much. I felt that I wanted to go like with like $1,008. I love this. So maybe the fee B, mean fee B, is the guy. So yeah, this guy. Maybe we can change it. So, but
presumably,
Go ahead.
Mix, presumably the why of these numbers and the way this is set up. I mean, if one could understand the math of some of those research papers, input, outputs, put out, that would say why.
Probably. Maybe it's not. Maybe they are running some tool inside organization to find that sweet spot. That's all. And
So
then,
they're just doing it.
go ahead.
All right. No, I'm just thinking that it sounds like the way I got through my math classes in high school was just guessing.
Yeah.
Yeah, actually, we are at the level of guessing. I mean, what we can do. Like, okay, something we can understand. Like, okay, a slot length here is one.
We could also manipulate
This is it.
the maximum Loveless.
Yeah, here is maximum.
Yeah.
This maximum Lovelace for Cardano was 45 billion ADA. Now it's not.
Right.
So we can change it.
Maybe that's also the reason why it stops to do things the private testnet. If that amount is reached with the epochs, with the how is it named, the rewards you get for staking.
Yeah. Exactly. And the one thing that actually we discussed and we didn't found out, there is a fee right now, right? In the mainnet, this fee goes to treasury, and some of them goes to the stake pool, some of them goes to Catalyst. But the question now is, where this fee,
To
the
be
fee
honest,
in
I
our
think
system goes?
I think
Where
that's
then?
not done in at the protocol level. I think that's done with native scripts, I guess.
Let's see. Native script. So it's old school. But Elia, would you please change the decentralization parameter? This is a K parameter, I think, or no? There is a security params, which is 10. Maybe that's a K parameter. I don't know. But let's change the mean fee B as well. But first,
Up
please
or down?
I want to go to upper and see hitting the limit, but we need to search mean fee B to find where it's located, and then changing them.
I think that's
So
it's the same files.
So it's 15,000 something. Well, let's add 10, or
Yeah, let's add 10.
yeah, 10. Let's see. I want to see like there is some hidden error, like there is a crying face Cardano CLI throughout, like, hey, you broke me or something. Yeah, we want to find those Easter eggs by breaking it down. But that's a good thing. And I always wonder that what are these numbers and how they are related to each other. But now we have a tool to do it, just to see and understand. And eventually you might say, okay, what's the point? Well, eventually, guys, each of us, we will reach maybe a resolution with ourselves, or a kind of an understanding that, hey, we need to start our blockchain within the Cardano ecosystem, of course. Okay, if we, wow, 1 ADA, so it became kind of 10 times.
Yeah.
So yeah, okay, that means B is more expensive, or it has more impact.
Yes, more impact. But we also increased it a lot more than the others.
But let's decrease it. Let's see how much, like go with 1. Like Adrian, go with 1B, 1A. Mean fee
Okay.
A and mean fee B, both of them 1. You know, 0, I think we can test it, but I think that's a next thing. Let's go for the 0. Like the fee is 0, you know. So now see it. When we will see this, maybe it would be interesting. That imagine these are one Lovelace. I mean, I think those are Lovelace, and let's go for 1 Lovelace. When 1 ADA is equal like $100 or $1,000, we might reach to this stage. Let's see the future now, that what our fee would look like. But yeah, I was saying that we need to think about starting the blockchain and creating this whole ecosystem. Wow, look at the fee. 388, Lovelace.
Now
It's
go
still
with
maybe
0.
expensive, right? Oh yeah, let's go for 0. And I imagine if it is 0 and we see again some Lovelace, well, maybe we need to look somewhere else to change the fee. Maybe there is some hidden fee or something. 381. Yeah, I agree with you, James. And errors, yeah, I agree with you guys. They are focusing mainly, I mean, it's there. Supposedly there are 3 organizations. IOG is doing the technical, Cardano Foundation is going to do the like software, like IOG doing hardware, Cardano Foundation doing software, and Emergo doing like something like a corporate
No.
level and stuff. 0. Okay, village
No
level.
hidden fee. So just these two parameters.
The these 2 parameters are the fees. So you guys, if you see in future that there is a vote for these 2 parameter, it means this is about the fee of the network. Okay, that's a today lesson. But I wonder if we go one of them 1, like what will happen? But let's go with 1-1, and
Yeah,
change
1-1.
something else. I wonder.
We already had 1-1.
No, 1-0, like 1 out. One of them 1, another 1-0. Like A1, this 1-0.
I think it's enough to change it just in the make files. Let's try that.
Okay.
So now we have just min fee A as 1 and min fee B as 0.
By the way, probably we can go with some rational numbers, also like 1, like 0.10001 something. But yeah, that's the thing. And also about the
Do you
size
think
of
we
the
can
block.
go with rational numbers? I don't think so. I
Yeah.
think that's 1 ADA.
After this, we will try it. It is a 1. I think it's a 1 Lovelace, but let's try it. Let's see that maybe they implement this hidden thing that they thought that, you know what, one day we have Ada, now Lovelace, and that time we need to introduce.
Now it's nearly at the same as we had with 1-1.
381.
That was 1-1. Now we have 1-0.
So mean A is more effective on the transaction than mean B, mean fee B. But let's try
Let's
it.
try the other way with 0-1.
I think it would be 1, apparently.
Yeah, let's try it.
Yeah. And let's then test this. So yeah, at that time, maybe there is this new, I don't know, the currency, what do they call it? Currency title? Currency, like, what do they call Lovelace? What is Lovelace as a currency title? Something like that. We have Ada, Lovelace, and then maybe Hoskinson. Maybe he put that his name under that, one day we will call. But if we see, guys, inside this make file, I think these are the important factor about this private. So
yeah, it's 1 mix. You're right.
So at the end, go with rational, some like 0 point something. Not yeah, exactly. Let's see that does this work. And if it works, it means the protocol accepted, but we just don't have a word for it. If it is like 38,
so it should be 38.
Yeah, 38, like we're 10 times smaller. And if it is really, so there is a room, but we don't have a name for the room yet. Did we break it?
Yeah, I'm not sure.
Because it doesn't work, right? The node doesn't run.
Yeah, looks like.
Okay, guys,
such a satisfied. Did we break it?
That was the whole point of this session, right? I mean, breaking the blockchain and see, doesn't feel satisfaction, you're like, I don't know, it's kind of on-chain orgasm or something.
What? Oh gosh, she dreams in color.
So yeah, I think we broke it. Doesn't work.
Yes, looks like.
Yeah. So okay, so we don't have something less than one Lovelace. At least this can prove kind of the hypothesis we don't have. But if you see that if we go with the lowest of lowest, still we need to pay like 300 something Lovelace for this script. And yeah, this might sound very cheap right now, but imagine if the crypto market as a whole goes to hundreds of trillions of dollars, and ADA, whatever it is, it's become much bigger. It goes like $10 trillion is the Cardano. These Lovelaces are something. And I think in that time, yeah, we need to introduce it, and probably we will have new Cardano, no Cardano CLI node, something that handles this new, like the rational of Lovelace or something. But I wonder if it is possible even. Maybe if it is not possible, and we need to go, in that time, we need to go with some kind of side chain or parallel chain or something. Like instead of rely on one mainnet, therefore it's expensive, the mainnet within itself, as I said, with that Mamba protocol, will divide to multiply mainnet. So each mainnet have 45 billion ADA and Lovelace. So it's kind of, instead of minting new ADA or something, we will mint blockchain. Right now we are doing that. Like that, this is a minting blockchain. Maybe that's a catchy name. We can, hey, what do you want to mint a blockchain? That's a bash script for that. But I think they thought about it, and on that time, maybe that's the inflationary mechanism. So like, if the Lovelace get expensive or something. But yeah, thank you, Adrian, and everyone. I think we are around the system. But if you think to break something else, like we already broke it, and I showed you how to change this magic number. I mean, in the VS Code and also in Vim, there is this search. You can just, but you need to again remember that there is this underline AB. Just click that so you don't change all the thing, like all the numbers. And yeah. But do you guys have any suggestion for breaking the blockchain? Do you have any hypothesis? Do you want to see some kind of suffering this blockchain gets and we enjoy from that kind of suffering? Let out of your system if you have the opportunity now. If you hate, if something was bothering you from this, you have the opportunity. But otherwise, yeah, we can have the session. And but Adrian, have you pushed the code? Those codes?
No, I will do that after that session.
Thank you.
Mixon, maybe you have time next week or so to talk about the governance stuff. So
Sure. We will assign a session together, and using maybe the implementation I've done in that branch, the other branch, or we can come up with something. For example, right now the admins are like, there is admin wallet, but if you remember, I implemented admin UTXO. So again, we don't want to trust the admins.
It's a huge upgrade. That's a really big upgrade.
So we can go with that admin UTXO, and then we can put that inside the contracts. What contracts? The contracts who is going to govern the governance. So yeah, sure. we'll talk about it.
I was just responding to somebody in the student chat who couldn't commit to module 201, and they shared a screenshot. And this is kind of interesting, just in the basic context of what we're talking about. There's a space on whatever page this person was trying to commit, which is not actually what's on chain, right? So they're trying to commit on a button that says module space 201. And there is no module space 201 on the treasury datum. There's no space module 201. So I'm not sure how that little bug got into the front end, but we'll have to fix it. And it's kind of a neat little scenario that shows, like, in a really simple case, what that treasury datum is doing. Just a little digression. Great session, guys. Incredible.
Yeah, thank you. Thank you,
Okay.
everyone. Thank you, Adrian.
I'm pumped to keep going next week. But for now, happy weekend, y'all. Hope people get a little bit of time off.
See you.
Thanks,
see you
Mix.
guys.
Nice to meet you. Is this your
Thanks,
first time
Adrian.
dropping by?
And if you guys again have a question, sure, ask. I haven't, maybe we haven't published this repository somewhere. I don't know, maybe somewhere in the Discord server. We will publish this repository, and I hope we will upload this video on YouTube. It would be open. I think it's fine.
Yeah.
It will be open for everyone, so you can check it out later. But yeah, if you have any question, please ask. If you find something, please share, because, you know, again, these are really new to us, and it's really exciting. We can explore a lot of stuff together.
I'll add this link to the PPBL website. It's
Sure.
already live streamed on YouTube, so we've got it
And
there.
the next system, you might guys, okay, what is the next system? Well, I don't know when, maybe next week, I'm not sure, but in coming weeks, in one of these sessions, we will try same thing with Hydra.
Yeah.
Run Hydra and try to break Hydra, you know. Let's not think about application. Let's think about breaking, enjoy, you know, get satisfaction.
Oh, it's
from
always
breaking,
give and
then
take. Yeah, no, I mean, it's thrilling to be moving back and forth because we have immediate needs for Hydra, right?
Yeah.
And it's going to be, to show that in the context of what people are already understanding is going to be really exciting. Hey, here's the problem Hydra solves in this case. Cool.
So yeah, see you guys, and thank you for your time. I hope we will upload this video as soon as possible, and those links. And I will going to reply to that announcement in community with these links. But inside the YouTube video, we will put this link at the
Perfect.
description as well.
Perfect. Yeah, you'll find it there.
Yeah.
All right. Thanks, partner.
Yep.
And yeah, Richard, is this your first time dropping by?
Yeah, here it is the first time, yes.
Welcome. Will we see you again?
I think yes, because I've really find it interesting, and I cannot make much questions because I'm still learning the basics, but I think this helps a lot. Yeah, so
No problem.
I hope,
Welcome.
yeah. Thank you very much.
Welcome to
Thanks,
Fight
It's nice
Club.
to meet you, Richard.
Yeah.
I saw that you had followed me on Twitter, so now that I see you in real as a real person, I'll follow you back. So thanks.
Yeah.
Cool. right.
Also,
Hey.
Roberto, I think I've been writing with him a few messages in the last days, week, but yeah, just good to meet you all, and have a nice weekend.
Yep, you too.
Thanks.
Okay, welcome.
All right, have a good one, everybody.
Yeah, see you guys.